Okay, ladies and gentlemen, out there in Algebra 2 land, let's look at a very simple example of analyzing a quadratic function. And we're going to analyze this very simple quadratic x squared plus 2x minus 8. We're going to go top to bottom. We're going to just, I'm going to have my notes out. You should have your notes out to see what we're going to do. And the very first thing that we're going to do when we analyze this function is we're going to find the domain. And we're going to realize that the domain of a quadratic function is all real numbers. So we still have some work to do to find the range, and we will find the range. The second thing we're going to do is we're going to find A, B, and C, because we're going to need the A, B's, and C's to analyze that function. Keep in mind, if you ever need to, if I'm going too fast, you can always pause the video to keep track of your notes. This will help you on the assignments that are due Friday. So I can find the A, B's, and C's. The A is equal to 1, B is equal to 2, and C is equal to -8. There's your 1 right there. The 1 is disguised. The B is right here. This is your A, this is your B, and this is your C. The A is going to tell us a whole lot of information. The A is going to tell us whether the graph opens up or down, and why. Then we're going to use that with the A. So what do we know? We know that since A is equal to 1, which is greater than 0, A is positive, the graph opens up. If the graph opens up, well, and we know that the vertex is a minimum point. That's going to be key information. If A is equal to 1, the graph is going to open up, and the vertex right here is going to be a minimum point right there. Very, very important information. That's if the A is positive. We have very simple A, 1. And the next thing we're going to do is we're going to find this rascal right here. We're going to find that vertex, and we need our notes. How do we know the vertex? The vertex is going to be negative b over 2a, f of negative b over 2a. This guy, when you first look at it, it looks like freaky, a bunch of letters, but not so much if you find the negative b over 2a. And if I look, hey, what was b? B was 2, negative 2, a was 1, so it's going to be negative 2 over 2 times 1. That's going to be negative 1. And now to find the y-coordinate of the vertex, you just put this guy into the function. Right here you go. The function was this. Maybe I better write the function down again. Function was this, x squared plus 2x minus 8. And I'm going to put this guy negative 1 into that function. And bam, what do I get? I get negative 9. And that's the vertex is negative 1, 9. That's our minimum point. And since that is a minimum, and since this is the y-coordinate of the vertex, that's going to help us with the range. Now we're going to name the range. And what is the range? All the possible y values, if I can spell range. That range, since the graph opens up, the range is going to be all y such that y is greater than or equal to negative 9. So it's all the y's greater than negative 9 because it opens up. Need to get your head wrapped around that, ladies and gentlemen. All right. What's the next thing we're going to do? A lot of information, Lee. I know. Well, now we want to know where the graph increases the intervals, you silly head. The intervals, ALS, why don't you just write that correctly? Intervals, intervals of decreasing and increasing. Well, look what's happening. This guy is going to decrease, and then it's going to increase. So it's going to decrease. Keep in mind this point right here is negative 1, negative 9. It's going to decrease to negative 1 and then increase. So let's write that down. The graph decreases when x is less than negative 1 and increases when x is greater than 1. Hey, pause the video. And now we're back. Right? Let's see here. What's the next thing you want to do? Well, the next thing you want to do is find the y-intercept. Oh my. Oh my. Yeah, oh my. The y-intercept for any quadratic is very, very simple. And what's the y-intercept? You just put 0 in. It's just 0c. The y-intercept, that's why these A, B's, and C's are so important. We need the B to find it. We need the A and the B to find the vertex. We need the C to find the y-intercept. So the y-intercept is 0, -8, because that's what C is. So let me take the revealer off here, and let's zoom out and look at this first page of this analyzing this quadratic. So there's the first page. Okay, I found the domain, found the ABs. I found that the graph opens up. I found the vertex. From the vertex, I can name the range. Happy daggone New Year. And knowing that the graph opens up and there's a minimum point, I could talk about when it decreases and increases, and it decreases to -1 and then increases to from -1 when x is greater. And then I found the y-intercept, which is simply 0c. Okay, let's zoom back out and finish this problem by, we got a lot more work to do. We don't have a whole lot more work. I'm going to put my revealer on. I'm going to go to the next page. And the next thing I'm going to do is I'm going to find, I will tell you, this is probably the hardest part of the whole process, is finding the x-intercepts, okay? How do you find the x-intercepts? Well, we're going to have to use the quadratic formula, and we're going to use the quadratic formula because we need to know when the output of the function, i.e. when f of x is equal to 0. So we need the quadratic formula. And one nice thing, and there's not a whole lot of nice things, I'm going to tell you about it now. One of the nice things about this whole virtual learning, you get to use your notes. Do you need to memorize the quadratic formula? I don't really know. We'll talk about it next year in pre-calculus, but I mean, if you use it enough, you should what you need to do is understand that this is giving you the solutions to a quadratic when a quadratic is equal to 0. So I'm using this right now to find out this. You can't solve for x because you have an x squared. What do? You use the quadratic formula. And the first step in using the quadratic formula is to find this bad boy right in here, which we call the discriminant. We call it the discriminant because a discriminant tells you about something. And we're going to look at this discriminant, which is b squared minus 4ac. So we're going to put here's the b again. A was equal to 1, B is equal to 2, C is equal to -8. We've already decided that. Now I'm going to put the B in for the 2 in for B squared. That's going to be 4. Minus 4 times C, or times A, which is 1, and C, which is -8. 4 times -8 is -32. 4 minus -32, what do you get? 4 minus -32 is equal to 36. That's going to be nice. Now we know, since the discriminant is positive, there are 2 real x-intercepts. That graph is going to cross the x-axis. Well, we have to find them. Now we know it crosses the x-axis, so that's very important looking at the discriminant. But now we have to find it. And what we're going to do is we're going to put that discriminant into the quadratic formula and find the x's. Well, if I put 36, and what's the square root of 36? 6. So it's going to be -2 plus the square root of 36 over 2a, which is -2 plus 6 over 2. 4 divided by 2 is 2. And then it's going to be -2 minus square root of 36, -2 minus 6 over 2, and that's going to be -4. So these are my x-intercepts. Yay! So what are we going to do now? I think now We're ready to graph this rascal. We have the Y-intercepts, we have the vertex, we have the X intercepts. We know it opens up. So let's go ahead and graph that rascal, and I'm going to turn off the revealer. I'm going to show you the graph. I'm going to tell you what, these are pretty easy to graph. Here you got your vertex right here. -1, -9. You have 0, -8. You have 2, 0, -4, 0. The other thing I haven't talked about is this rascal right here. And let us not forget about this. This thing is a line of symmetry at x equals the line of symmetry. We're going to talk more about this when we get back from Thanksgiving break. But the line of symmetry right there, ladies and gentlemen, is x equals -1. We got to start thinking about it now, but we're going to talk more about that. But that means, just like the video said, that if you take this half of the graph and flip it over, it's going to match this side perfect. Okay, I've got the vertex opens up. I got, hey, what are you going on here? It's decreasing. What? And then it's increasing. Opens up. X intercepts, Y intercepts. I don't think there's not much more to that. Let me go out to view the whole thing. So you can always pause the video. So this is what you're going to want to do with one. There, you have to do this twice on the homework. And I'm going to be looking at all of this stuff. I'm going to be looking at, whoopsie, all of this. The domain, A, B's, and C's, open up or down, vertex, range, where it's increasing, decreasing, the Y-intercept. Pause the video if you have to. The X intercepts, bam. All right, so a good example. This will be an example for your homework. So catch you on the flip side.